M308 kids. I know that it's a test day, so I thought I would make a video just to help out with some problems. If you want to take a look at these, if you're struggling with any of them, it might be a good idea just to check out the problems. So the first one, this is all from Review Worksheet 5. I'm not sure which problems Mrs. Young chose to do, so I'm sorry if there's any repeats. But I'm starting with number 10. This is an arbitrary solution problem. So right away I would try to solve this using, personally I would try to use elimination just to get started because it doesn't give me a strategy, so it's kind of giving me a clue that it's going to be a special type of problem. So if I multiply everything by -2, I get -4x minus 2y equals -6. And if I use elimination, then everything's going to cancel out. So it's in Algebra 1 we would say all real numbers, or infinitely many solutions, because we get a true statement, 0 equals 0.
Infinitely many solutions.
Okay, my husband's making fun of me, so that's nice. But in Algebra 2, we write our answers with an arbitrary solution. In other words, arbitrary is just like a random selection. So this instruction said to let x be arbitrary, which means we want our answer to be x, comma, something that has an x in it. Okay, so when x is arbitrary, we're actually going to solve for the opposite letter. So we're going to solve for y, because what we want is y in terms of x. All right, so I think it's easiest to use the second equation, but you could use either equation to solve for y. You should get the same thing. We get 2x plus y equals 3. So if I get y by itself, that's what solving for y means. I get -2x plus 3. So what this means, bless you, what this means is y is equivalent to the expression -2x plus 3. So if I write x arbitrary, then the first answer would just be x, and the second answer, instead of writing x comma y, I'm going to replace y with the expression that's equivalent to it that has an x in it. Oops, so we got -2x plus 3. So this is how you would write an arbitrary solution with x arbitrary. If it asked for y arbitrary, then we would get x by itself and write the x part in terms of y. Okay, so that's the first one. That was number 10. Moving on to number 17. This says solve the system of equations using inverses. This is a graphing calculator problem. I'm going to use the app to do it. So the first thing to note is that the coefficient matrix is 3, -4, 2, 2, -1, 1, 1, 2, -1. And that's Dean Scott in the background making his appearance. Yeah. Yeah. Okay, so what we want to do in order to solve using inverses, first we want to find the inverse. Dean's excited about this math. I don't blame him. All right, so I'm going to go ahead and go over to the calculator to use the calculator to find the inverse. So we got 3, -4, 2. So we're going to go to the matrix. And we're going to do a 3 by 3. 3, -4, 2. And 2, -1, 1. 1, 2, -1. Yeah, that's right. And we're going to raise this to the negative first because we want to find the inverse. Okay, there it is. So this is this 1/5, 0, 2/5. That is the inverse. Okay, I'm lazy, so this is what I'm going to do here. All right, so, uh-oh, that backfired. Here we go. So here is my inverse matrix, all right? In order to solve using inverses, I'm going to take the inverse and I'm going to multiply it by the solution matrix. The solution matrix is this. So 15, 13, 5. And again, I'm going to use my calculator to do that. So answer, if I just press the multiplication symbol, it's going to take the previous answer. So answer times solution matrix. Ooh. Yeah. Let's change this. It's going to be 3 by 1. There we go. So it's times, what was it? 15, 13, 5. And there it is. So the answer is 5, 3, 6. X, Y, Z. Okay, so this is how you solve using inverses. If I was doing a 2 by 2 and had to show the work by hand, I would just use the inverse formula to find the inverse of the coefficient matrix and then use matrix multiplication and multiply it by the solution column. So that's the deal, you guys. Again, for this, we would write the inverse here and the solution there.